One on time. 11:14. Okay, I think we can do it. Let's try it. We're going to get a little bit further, a little bit closer to equilibrium, and we're going to utilize this stuff that we just figured out here. Before we do that, let's get to the reaction quotient. And what's the symbol for reaction quotient? Yep. Chalk is disappearing on me. Okay, we're going to consider a reaction where we have a product A being converted to product B. And this is a gas phase. We have A. Okay. What's changing in this? Or what definitely has to change with the chemical reaction? Yeah, moles definitely have to change. If we're talking about change in moles, we have to consider chemical potentials. It's always what minus what? Final minus initial, or when it comes to chemical reactions, products minus reactants. We're going to take the stoichiometric coefficient of B. What are we going to multiply that by? We're talking about change in moles. We got to consider this property. Yep, we got to look at the chemical potential minus A times chemical potential of A. Since we're looking at a gas, let's assume ideal gas behavior. Oops. These mu's, we can express them as the standard mu plus that RT thing that we derived already, right? So we'd get B mu naught of B plus RT ln pressure of B minus A mu naught of A PA. Let's distribute the B's through and the A's through. I'm going to do something a little strange. I'm going to pull these two mu terms out and near each other. Oops, I didn't distribute an A and a B. You've seen that before. What is that? Or how do we define G of reaction? Stoichiometric coefficient times mu of B minus stoichiometric coefficient of A. Oops, these should have been capitals. Sorry. Better. So what's this thing? Yeah, delta G naught of reaction. If you calculated that a ton of times. Okay, now we're going to use some properties of logs. Oops. What could we do here? I want to combine these two terms. The A and the B prevent us from slapping those things together. What do you suggest to do? What's that? Can't just pull that guy out. What else could we do? Make it an exponent. Let's do that. Drop things. What would we raise PA to? Yeah, little a. Okay, now can we slap those things together? Still not exactly what I want. What could I do here? Stack them. We did it. It only took us a semester, but we did it. What is this thing? It's what over what? For equilibrium? Products over reactants. This isn't K quite yet, because what's K? That's Q. If this is 0, what is this? Then it's K. This is Q, the reaction quotient, and that's where it all comes from. You pull out those stoichiometric coefficients. You were always told, pull those stoichiometric coefficients out, right? That is why. Just this bit right here is Q. Next time. What time is it right now? Oh, crap, sorry. All right, next time what we'll do is we'll come up for a generic expression for this, and then we'll show where K comes from. We're right on the cusp, and then we're done with equilibrium. We can talk about thermodynamics, and we can finally talk about kinetics. Okay?